Hello, it's Adam from Rebel Technology. I'm here with the second in our series of tutorials showing you how to build patches in pure data and get them running on the OWL. So, today we're going to learn how to build a simple sampler looper, which is great for impressing friends and family. It builds on some of the stuff that we learned in the first tutorial, which you can find in the Rebel Technology website under the Educational tab. Now, let's get over to pure data and we'll start a new patch. Pure data records audio into an object called table, so we'll begin by creating one of those. Table needs to have a name, which can be anything. I'll call it sampler. And it needs a length, and that length in samples. Now, the sample rate of the OWL is 48 kilohertz, or 48,000 hertz, which means that 1 second of audio is sliced into 48,000 separate samples. So if we wanted to make a sampler that could record up to 1 second of audio, we need a table that was 48,000 samples long. I'm greedy and ambitious. I want to be able to record up to 3 seconds of audio. So this table needs to be 3 times 48,000 samples long, or 144,000 samples long. So put that in. Now, to get audio into the OWL, we need to use an object called ADC. And that's another tilde object. You can see it has a left and a right output, and that corresponds to the left and the right input on the OWL. And to get that into the table, we use an object called tabWrite. It's a tilde object. It needs to be told which table to write into. So sampler. We connect the audio output from ADC directly into the tabWrite object, and it's ready to write into the table. Now we need a way of controlling that, and I'm going to use the push button on the OWL. To access that, we type R channel push. Now the push button will output either a 1 when it's pushed or a 0 when you stop pushing it. And we need to turn that into something that's useful for the sampler. So first we're going to use an object called select or sel, S-E-L. And this is an object where you tell it what to look for, and we want it to look for 1s and 0s. We connect it to channel push. Now, when a 1 comes into it, it will send what we call a bang out of this outlet. When a 0 comes into it, it will send what's called a bang out of this outlet. Anything else just passes out of this outlet. So we can use that first bang from 1 to start writing into the table, because a bang will trigger the sampler. But to stop the sampler, we need to send what's called a message. Now, Apple II will create a message here. You can create a message in the put menu as well. And I know that the stop message will stop tabWrite. So I connect that. So the bang hits the message and sends the stop message into the sampler. You can see how the message looks a bit like an object, but it has a slightly indented edge. Now, different objects will need different messages to make them do different things, but you pick those up as you go along. So here we have it. We've got a way of getting audio into the OWL and starting and stopping recording with the push button. How do we get audio out of the OWL? Well, we've got an object called tabRead, which will read from the table. And we need to give that a name, sampler, so it's reading from the right table. And we can connect that straight to the audio output. Now, if you input the position into tabRead, it will play what is at that bit of the table. So we need something that moves through all the positions in a smooth, linear manner and does it quickly as well. And the best thing to do that is a phaser object. That's a tilde object. Now the phaser object will move from 0 to 1, 0 to 1, 0 to 1, 0 to 1, repeatedly and smoothly. So that's perfect, except we don't want it to go from 0 to 1. We want it to go from 0 to the end of the sample and or the end of the table, and that's going to change depending on how long the recording is. So it's got to be multiplied by something, but we don't know what. So we'll do a multiply tilde, and for now we'll put in 1, and connect that. But you can see here that there's a right inlet on the multiply tilde 1, and if we put a number into this right inlet, then that will update whatever the 1 is, and we can change it and multiply it by however long the sample is. Now, as has become evident, we need to know how long the recording is. So we can do that with an object called timer. Now, timer takes a bang in the left inlet to start it recording, so we'll use the bang when you press record, and then a bang in the right inlet to stop recording and output the time. So we use the bang from the 0 when you wanted to stop recording, and that will output the time in milliseconds. Now we want to do a few things with that, because we want to calculate how much the phaser should be multiplied by, and we also want to calculate how fast the phaser should be. When you need to do a few things with one number, you use an object called T, which stands for trigger. I'm going to type T, B, F, F. Now that means trigger, bang, float, float. And float is a floating point number, such as the output of this timer. And it does the output in a very specific order of right to left. So it will trigger a float, and then a bang. So every time we output a length of recording, so basically every time we stop recording, we'll send the length of the recording, and a bang out. And that's very useful, because that will let us start playing things back properly. So we're going to send the first float. We're going to use that to find out how much phaser needs to be multiplied by. Now the output of the timer is in milliseconds, so if we multiply that by 48, then we'll get the length in samples of the recording. So that's what the phaser should go through. And now we need to calculate how fast the phaser should be to play back the sample at the correct speed. And the maths to do that involves divide by and a message with 1,000 in, and we want to connect the time in milliseconds into the right inlet to divide by. We want to have the bang hit the 1,000 and go into the left inlet of the divide by, and that is the inlet that triggers the calculation. So it's very important that we get the time first, and then we get the calculation triggered by 1,000, and then we input that into phaser, and that will set the phase, or the frequency rather, of the phaser, and play back the sample at the correct rate. So we can check that that's worked by quickly placing a toggle object, which will output the same as channel push would, turning audio on, record. So there you go, our simple sampler looper. So now we've got the sampler running on the OWL, and it's listening to some Cyndi Lauper, which I've got on my iPhone. If you want, I can catch you,